The plan that AEMO has presented does not pass the science test, it doesn't pass the engineering test, and as we're finding out, it doesn't pass the consumer test. And therefore this plan needs to be challenged. And I think we need to understand just how dangerous it is to take a plan that is already failing and amplify its sources of failure in order to try to make it work.
At the moment, we're globally facing two crises, climate crisis and the loss of biodiversity. And tackling these challenges boils a lot down to energy policy. And in energy policy, one highly debated issue is the role of nuclear in the future. The problem we're facing, the parameters we're facing, the amount of energy we need to decarbonize, to get rid of fossil fuels and ensure human development. What are the actual tools that can be used? What is the portfolio that we should have of different energy sources? Are renewables alone enough? And I encourage everyone to do this math and kind of look out as robust strategies as possible for tackling these global crises. This is what the Greens in Finland have been doing, and as a result we've actually adopted a more technology neutral, pragmatic and to some extent pro-nuclear stance on energy policy.
No other G20 nation is still working towards an electricity grid nearly exclusively powered by intermittent flows of energy. The Japanese, the South Koreans, and other serious nations all understand that we will always need a large amount of base load and flexible power to work alongside a sensible amount of solar and wind. Hasn't yet worked anywhere at scale, and certainly not on an isolated grid like Australia's. It essentially treats these different generating technologies as competitors in a winner-takes-all popularity contest. And unfortunately, this is why the Energy Minister can continue to insist that by adding more solar and more wind to our nation's grid will bring down energy prices. That's in the face of all real-world observations to the contrary. So using a systems approach to intelligently combine technologies in a way that's complementary is much more sensible than trying to pick winners. Instead of building a grid that is simple to operate and minimises costs to the end user, we are getting ready to build a grid designed for investors, okay? To connect far-flung renewable projects and to maximise the transmission access they have. The operators of this future grid will be forced to accommodate or absorb every last renewable electron, regardless of the mismatch between their production and actual customer demand throughout the day. So, in short, it's unlikely this plan will work, and while it's probably hard to believe, our energy situation stands to get worse. Structurally expensive electricity, loss of energy-intensive industries, and more frequent blackouts by 2030 all seem very plausible. Coal to small modular nuclear reactors is the sensible transition that we need to start working towards. It makes the best use of the existing grid to provide always-on, zero-emissions, affordable power. Pursuing a nearly 100% grid requires an enormous amount of batteries, and everyone is going to be trying to buy the same batteries from the same factories at the same time. They don't want to get into an international bidding war for scarce batteries.
The Reserve Bank of Australia Governor Philip Lowe has issued a blunt warning saying that the renewable energy transition would probably spark higher and more volatile energy prices in the years ahead. It was actually the first paragraph in the article in the Fin Review from a speech I think he made at the CEDA conference. Now, the only thing I would disagree with, I would probably not use the word probably. I think that there's a much higher level of certainty that that's exactly what we're facing. The reason I was pleasantly surprised is I've been trying to give this message for 3, 4, 5, 6 years, privately and publicly at conferences, and so to hear that the message is now getting through to people like Philip Lowe is quite encouraging. The problem in my view, is not just the transition. People will say, oh yeah, it's a transition problem. Transitions are hard, of course they're hard. I think the problem is the destination. We're being told, we're being sold that you can have a system configuration. There's no evidence whatsoever that it's actually going to work. If we can make it work, the evidence is it's going to be extremely expensive, or reliability and power quality, frequency all over the place, voltage all over the place, is going to be compromised, or a combination of both.
There are 4 scenarios. There's a step change scenario, slow change, progressive change, and hydrogen superpower. Now, with my modelling, I've been able to model all those, and there's a common thread. And what I look particularly, and I teach this to my students at the University of Wollongong, is that when you do these plans, you look at the end game, and the end game for this plan is 2050. Do I want to end up where this plan leads me in 2050? Now, if I go through my modelling, what it shows is that I'm going to have blackouts in 2050. It's not going to work with the resources that I see inside the plan. In fact, I need 40% more resources, 40% more generation, 40% more storage, and more transmissions required to make that system work. We're in this very delicate situation at the moment. We're 15 years into a transition, and it's just getting worse every year. All the easy fixes are gone, and we are heading for a very difficult time ahead. There's no easy fix to the problem that we're in, and no matter what we do, it's going to take 10 or 15 years to get out of the situation that we're in at the moment.
Well, from an engineering point of view, most people would agree it's all about the numbers. And regrettably, after studying the AEMO plan for the future, the numbers just don't cut it. Now, the reason boils down to a major factor, and that is there's an attempt to put so many renewables into the market, which are highly variable, intermittent, as everyone knows, and there's insufficient baseload power generation. There's completely insufficient storage as well, so that the grid is unstable and it's insufficient power many times to cover the maximum loads.
Solar panels, turbine blades, and batteries will need to be replaced about every 20 years. We can't even recycle them. There is no viable method at the moment for recycling these things. They get just thrown into the tip, into landfill. The approvals processes for the thousands of kilometers of new transmission lines have to be approved. We have trouble even getting one approved. There's one at Daylesford at the moment that's been contentious for some years now. And clearly nobody wants a transmission line on their property. Neither would your voters in your electorate. Every line is bitterly contested. Can you imagine, those of you who have a property, someone says from government, here, I'm here to help. We're going to put a transmission line on your property and you're going to have to suffer for the rest of Australia. The explicit nominal costs of the ISP, according to AEMO, are only $383 billion up until 2050. Community capital costs, i.e. the solar cells that we each put on our rooftops, that's not accounted for. But AEMO are using those generation in their calculations. So effectively, we have to include those if we're looking at an Australian cost. How much are they? Well, it's unfortunately, AEMO don't tell us, but we've calculated they're about $240 billion. Hence, the total capital cost is not $383 billion. It's more like $623 billion. And then, of course, the lifespan of PV panels, wind turbines, and so on, means that you're gonna have to replace them about every 20 years. So what does that mean? Well, that means that if you said, say, 50% of them the cost has to be replaced, your all-up cost is $1.3 trillion. This is 5 times greater than the AEMO statement of $383 billion. They have to be held to account for that. Explain, how can you justify this difference? Fortunately, a consortium of University of Melbourne, University of Queensland, and Princeton, engineers and academics are partway through a privately funded project called Net Zero Australia 2050. I'm sure you've heard of that. There was a industrial and technical update last night. They showed maps with solar panel farms larger than the size of Tasmania. Yeah, right. Hydro dams, wind farms, etc. Massive, basically an entire restructuring of the Australian society. The estimated capital cost to achieve and maintain this scale of change are between 100 billion, these are not my numbers, these are theirs, and 150 billion every year, year in, year out, for the foreseeable future.
It takes a number of years to put a country, including a country like Australia, in the position to have the option to procure nuclear energy technology. We need to get in the game. We need to get on the vendors' order books if we want to have nuclear energy in our country. Now, you might say, as Adi said, well, how do we go about it? Well, the International Atomic Energy Agency has developed a standard approach. It's called the IAEA Milestones Approach in the development of a national infrastructure for nuclear energy. And countries, including 52 countries which are currently considering nuclear energy or actively implementing nuclear energy programs, these 52 countries use this methodology. It's a methodology or a toolkit. It starts from when a country considers nuclear as an option and goes all the way through to electrons on the grid. It's a very valuable toolkit. It was utilised by the UAE from start to electrons on their grid very successfully. So I believe that if we are to want to have the option to have nuclear energy in Australia later this decade or in the early 2030s, we must start the work now, and we should use the IAEA milestones approach to do this.
Yeah, baseload power stations of any sort of technology, not renewables, but baseload are going to be difficult to finance in the current market because of the way our energy-only market works. There is a hidden subsidy for renewables, and apart from a small amount of spinning reserve in each region, the renewables get preferential treatment. This is exacerbated by the solar panels on roofs, which is a sort of a negative load. It's behind the meter and you don't see it.
If you think like a juggler trying to hold a bunch of balls in the air, and he's got a bit of solar here, a bit of wind here, and he's got pumped hydro, and he's got a bit of gas, and he's got all of these balls. And when you look at the complexity of trying to juggle this, there are times when the wind and solar don't cooperate. And that's when we've got not enough reserve margin in the system, and that's when the costs go right up through the roof. What it means to mums and dads for commodities, but also the standard of living, this high cost in underperforming assets, driven by the huge numbers that Dave Collins mentioned, drives a massive amount of inflation into the economy. And it means that we will not have enough left in the pie for families to have a decent standard of living. And this is the net outcome, and so food prices will rise.
I'm qualified to say Australia is almost at, if not already at, crisis point. We, as we've heard previous speakers say, our time is running out to make sure we get stable, reliable, low-cost electricity. If you want to build industry, and I'll come to the mining and mineral sector later on, if you want to do that, you've got to have a reliable electricity supply that's not just low cost and reliable and robust, it's also a perfect supply 24/7 by 365. That's what you call a reliable grid. And Australia has got one of the largest grids in the world. It's also got to be globally competitive, that if we're going to continue to create more wealth in Australia, you've got to have our electricity supply at competitive global prices. We used to be number 3 lowest cost in the OECD. We are now at the last or top most expensive 3. With no reliable electricity, there's no industry. We can only do this if we have a change in attitude. This is an urgent problem we got to get on with.
The Indigenous community up here didn't realise how much of land was going to be covered by these solar panels. And how much that was going to be affecting their environment that they're in, and also their cultural heritage as well. That would be, which will be covered by this, because it completely covers this whole cattle station. 15,000 hectares of land, and people are not very happy about this.
The only way it survived was gas. So South Australia normally, they have to have an amount of gas on the system just to keep it stable. They've got the big battery, etc., but really they need a lot more than that.
Well, thank you very much, everybody. It's been my privilege to guide my colleagues through the process. I think that we've had the brains trust of Australian nuclear capability. You can see that we've certainly got the brain power. We just need a legal environment in which the brains can be applied to our future.